On Earth, the concepts of above and below are absolute, dictated by the unyielding pull of gravity. Up is away from the center of the planet, down is toward it. But leave our world behind, and these familiar directions dissolve into the vacuum. In the silent, weightless expanse of space, up is not a physical law, but a human invention. It is a choice we make, a line we draw on a map to orient ourselves in an environment that has no inherent orientation. To begin, we must choose a reference. Our most immediate one is the ecliptic plane, the thin, flat disk where the planets of our solar system conduct their stately orbits. This plane is a relic of our sun's formation, the leftover material from the spinning protoplanetary disk that birthed Earth and its siblings. When we align our perspective to this plane and tip the camera above or dip it below, the first impression is one of profound emptiness. Most of what you see is vast, nearly empty space. But this emptiness is an illusion of scale. The void is not truly void. Look closer, and you'll find a few rebels that defy the flat order of the solar system. These are the high-inclination objects, comets and asteroids whose orbits are tilted at extreme angles. They arc like cosmic needles through the solar plane, visitors from the chaotic outer edges. Objects like the comet Hale-Bopp, whose path was nearly perpendicular to the ecliptic, remind us that the solar system has a third dimension, a vertical depth teeming with ancient wanderers. Journeying farther out, beyond the orbit of Neptune, we encounter the Kuiper Belt. While often depicted as a flat ring, it's more like a puffy, donut-shaped cloud of icy bodies. The main concentration of objects lies near the ecliptic, but as we move to higher latitudes, further above or below, the population of these frozen worlds thins out, becoming a dim, sparse halo of primordial remnants. And then, at the farthest frontier of the sun's gravitational kingdom, all sense of a plane dissolves entirely. Here lies the Oort cloud, a vast theoretical sphere of trillions of icy bodies surrounding our solar system from every conceivable direction. It is the source of long-period comets, a perfectly symmetrical halo that defines the true boundary of our solar neighborhood. From within the Oort cloud, there is no above or below, only a uniform shell of frozen worlds in every direction. Yet even beyond the last familiar ice, the sun's influence persists. It carves out a colossal magnetic bubble in interstellar space, the heliosphere. This bubble is inflated by the solar wind, a constant stream of charged particles flowing from the sun. This wind races outward at 1,000,000 miles per hour until it slows abruptly at a boundary called the termination shock. Beyond this, it churns through a turbulent region known as the heliosheath, before finally yielding to the pressure of the interstellar medium at the heliopause, the true edge of the sun's domain. Two human-made emissaries, Voyager 1 and 2, have crossed that final frontier. After decades of travel, they are the first objects from Earth to taste the environment between the stars. Outside the heliosphere, they found the local interstellar gas, a medium 10,000 times less dense than our best laboratory vacuums. It is a thin, magnetized, and cold sea of hydrogen and helium with no surface and no shore. This is the true beginning of interstellar space. Here, our solar system drifts through a slightly denser wisp of gas and dust known as the local interstellar cloud. And this cloud itself is just one of many floating within an even larger structure, a vast 1,000 light-year wide cavity called the local bubble. Astronomers believe this immense void was carved out millions of years ago by a series of powerful supernova explosions, which swept the region clean of dense gas and dust. Within this bubble, we share space with our nearest stellar neighbors. Suns like Alpha Centauri, Barnard's Star, and Sirius dot the local neighborhood. But none of them sit above or below us like floors in a building. They simply occupy different coordinates in a shared three-dimensional volume of space, each following its own path around the galactic center. To make sense of this grander scale, we must change our frame of reference again. We can define a new up and down based on our home galaxy. If we align ourselves with the vast spinning disk of the Milky Way, then above points toward the North Galactic Pole and below toward the South. Looking in these directions, away from the bright, dense galactic plane, the star count thins dramatically. We pass through the thicker, older disk of stars and then into the vast, spherical galactic halo, a sparse realm of ancient stars and globular clusters. High above and far below the galactic plane, ancient globular clusters hang like distant, ghostly beacons. These are tightly bound, spherical collections of hundreds of thousands of stars, some of the oldest objects in the galaxy, orbiting the Milky Way's core on highly inclined eccentric paths, and enveloping everything. The disk, the halo, the globular clusters is an immense invisible architecture of dark matter. We cannot see it, but we know it's there. Its gravitational pull is what holds our galaxy together, preventing its rapidly spinning stars from flying apart. This dark matter halo is the true scaffolding of the Milky Way, a sphere of influence we can only trace by its gravity, not by its light. Zooming back into our more immediate galactic vicinity, we find our sun isn't in one of the main spiral arms. Instead, we ride a smaller, partial arm called the Orion Cygnus arm, or simply the local spur, and our local neighborhood is further defined by the Gould Belt, a massive tilted ring of bright young stars and stellar nurseries that slices through the galactic plane at an angle, currently passing right through our region of space. So, when we stack these references, the flat plane of the ecliptic, the teardrop shape of the heliosphere, and the sprawling disk of the galactic plane, a profound realization emerges. You see that above and below are not fundamental truths of the cosmos. They are simply tools, convenient conventions we create to navigate the staggering scales of space. We are not in the middle of anything by design or destiny. We are simply somewhere. Our position is a temporary address in a cosmic ocean, suspended between conventions that help us make sense of the deep. We are travelers, drawing maps as we go. So what actually exists there, in the spaces between our planes and bubbles? It is a tapestry of subtle structure. It is thin, cold plasma threaded with magnetic fields. It is clouds of neutral hydrogen gas, detectable only by radio telescopes. It is ancient star clusters, drifting ice from the dawn of our solar system, and the faint, ever-present gravitational pull of dark matter. On the largest scales, even our galaxy is just one node in a vaster structure, the cosmic web. We are oriented within the local group of galaxies, which itself is falling toward the Virgo cluster, all moving along immense filaments of dark matter that stretch between galactic superclusters and across colossal voids. And as our maps sharpen, thanks to instruments like the Gaia Space Observatory that chart the positions and motions of billions of stars, the perceived emptiness continues to grow more detailed, more complex. The void is not empty. It is a quiet, textured ocean above and below, a realm of subtle physics and ancient light. Each new map we draw reveals another layer, waiting for us to cross another boundary.